This is part 2 of lesson 10-4, and we're talking about radical equations. So in this video, we're going to focus on extraneous solutions. An extraneous solution comes from when you're solving an equation with a radical and you have variables on both sides of the equation. So what happens is you solve, and then sometimes the two solutions you get when you solve, if you plug them back into the original equation, they don't always both work. Sometimes one or maybe two of those solutions don't work in the equation. They don't make the equation true. So in that case, yes, mathematically you found a solution, but it does not work. It's called an extraneous solution. So we're gonna do about 8 practice problems here. Just jump right in. If you wanna pause the video to focus on this example they've written out for you, you can. Like I said, I'm going to do 8 with you right now. Not every problem has extraneous solutions. We're going to simplify, but the ones that do, we're going to look at what that looks like and when it happens. So they don't give me a lot of room to write my work, so I'm going to use a separate sheet of paper. If you're following along on the study guide, I'm doing number 2 first. This is square root of a plus 6 equals a. Square root of a plus 6 equals a. All right, to solve this, first thing we want to do is get the radical by itself on one side of the equal sign, and then to get rid of it, we're going to undo that radical, or we're going to square it, right? They're opposite operations. And whatever I do on one side of my equal sign, I have to do the same thing to the other. This squared sign and this square root sign cancel each other out, and I'm left with a plus 6 equals a squared. Now I have all the pieces of a quadratic equation. So I want to move everything so that it's all on one side of the equal sign, and I want 0 on the other side. I don't want a number in front of a squared. I don't want it to be negative or anything. So I'm going to leave that alone, and I'm going to get rid of these guys and move them over here. So I'm going to subtract a from both sides, and I'm going to subtract 6 from both sides. So once I do that, I end up with a squared minus a minus 6 equals 0. Now I can factor and solve for a. So I'm going to have 2 binomials equal to 0. Factors of negative 6 that add up to the middle number, negative 1, are going to be negative 3 and positive 2. So a minus 3 and a plus 2. Oh, I've got ink on my hand. So now we're going to use the 0 product property, which just says when you have terms multiplied together and the answer is 0, that one, at least one of those terms, must have been equal to 0. We don't know which term is 0, so we're going to solve both. We're going to pretend like this guy was 0 and this guy was 0. So if a minus 3 equals 0, what does a have to be? Positive 3. If a plus 2 is equal to 0, what does a have to be? Negative 2. So these are my two solutions. Now I want to plug them both back into my original equation and make sure that they both work. So first, I'm going to try a equals 3. So I'm going to have the square root of 3 plus 6 equals 3. And then if I start simplifying that, 3 plus 6 is 9. And the square root of 9 is 3, so I get 3 equals 3, and that is correct. Fantastic. Second solution is negative 2. So I'm going to plug that in. Negative 2 plus 6 equals negative 2. Okay, so now I start simplifying. Negative 2 plus 6 is 4. So I get square root of 4 equals negative 2. And the square root of 4 is 2, which is not equal to negative 2. So this is an extraneous solution. It's a solution. We got this once we solved, but when we plug it back into the original equation, it doesn't give us an accurate answer. It doesn't work. So we're going to write extraneous solution. The only solution here that works, I'm going to try and highlight it, is 3. And a equals negative 2 did not work. All right, next problem. On the worksheet, we're going to do number 3. And that says square root of 2 times square root of x equals x. 2 times square root of x equals x. There's a lot of moving around in this problem. There's quicker ways to solve it. I'm just going to stick to the same rules we talked about. We want to get the radical by itself. So I'm going to divide both sides by 2. And this goes away. And then I want to square both sides to get rid of this radical. So I'm going to square this, and I've got to square this. So once I simplify, this cancels this, and I'm left with x. X over 2 times x over 2 gives me x squared over 4. And I don't want my x squared term to be divided by anything. I don't want a fraction in front of it. So to get rid of that, I'm going to multiply by 4. Like, see, it seems funny because I already got rid of the 2 and now I'm moving it back, but that's okay. These 4's cancel and I'm left with 4x equals x squared. So now I can get both of these on one side of the equal sign, set it equal to 0, and solve for x, right? So I'm going to subtract 4x from both sides. So I'm going to have x squared minus 4x equals 0. And now I can factor. I can divide both of these by x, so I'll get x times x minus 4 equals 0. So either x equals 0 or x minus 4 equals 0, which means x would have to equal 4. So here's my two solutions. Now I want to plug them back up into my original equation to test them out and see if they both work. Okay, so 2 square root of, I'm going to start with 0, equals 0 over 2. Square root of 0 is just 0, right? So 0 times 0 is 0. So this is 2 times 0, and 0 divided by 2 is 0. So this is correct. Okay, and then second, I want to try x equals 4. So 2 square root of 4 is going to equal 4. Okay, square root of 4 is 2. And 2 times 2 is 4. So both of these solutions work. There is no extraneous solution. Both of these work. So we got this guy and this guy. Those are our two answers for number 3. Okay, next problem we're going to do, if you're following along on the study guide, is number 4 and then 5, and then we're going to skip around a little bit. So for number 4, the problem is n equals the square root of 2 minus n. Okay, so we want to get the radical all by itself, so it is. Then we want to get rid of it by doing the opposite, which is squaring it. And whatever I do on one side of the equal sign, I have to do to the other. This squared cancels the square root, so I'm left with n squared equals 2 minus n. I have all the pieces of a quadratic, so I want to move everything to one side of the equation and get 0 on the other. So I'm going to add n to both sides, and I'm going to subtract 2. So I'll end up with n squared plus n minus 2 equals 0. Now I can factor. We're building on all those skills that we've previously learned, so hopefully you guys are recalling all that. Factors of -2 that add up to +1 are +2 and -1. So n plus 2, n minus 1. 2 times -1 is -2. 2 minus 1 is still +1. Then 0 product property, I set each of these equal to 0 and solve for n. In this case, n is going to equal -2. And in this case, n is going to equal +1. So I've got two solutions here. Now I want to go back and plug them both into my original equation, make sure they both work. So first, I'm going to start with -2. So I'm going to have -2 equals the square root of 2 minus -2. Okay, then I can simplify. So that's -2 equals the square root of 2 minus -2 is really 2 plus 2, which is 4. And the square root of 4 is 2. And -2 is not equal to +2. So this is an extraneous solution. We solved and we got -2, but it doesn't work when we plug it back in. Let's try +1. So 1 equals square root of 2 minus 1. So that's 1 equals the square root of 2 minus 1 is 1. The square root of 1 is 1, so that works. So that's our one solution. This is our one solution. -2 was an extraneous solution. Okay, I hope this is making sense for you guys so far. All right, next, we're 3 down. We have 8 total, so we got 5 to go. Number 5, square root of negative a equals positive a. If you're following along on the study guide that I provided here on Schoology, we're on number 5. Let's see, what did I say? Square root of negative a equals a. All right, so I want to get rid of the radical sign, so I'm going to square this, and I'm going to square this side. So this cancels this, and I'm left with negative a equals a squared. And again, I want to move everything to one side of the equal sign, so I'm going to add a to both sides. And so I'll have a squared plus a equals 0. Then I can factor. So I'll have a out front and a plus 1 in parentheses. And so either a is going to equal 0, or a plus 1 is going to equal 0, so a will have to equal negative 1. Once I have my 2 answers, then I'm going to plug them in and make sure they both work. And put a equals. First off, square root of negative 0 is equal to 0. So that negative 0 is 0. Square root of 0 is 0, so that's just 0 equals 0. Check, that works. And then second, I want to plug in negative 1 for a. So the square root of negative 1 is equal to negative 1. So negative 1 is positive 1. Square root of 1 equals negative 1. 1 equals negative 1. It does not equal negative 1, so this is an extraneous solution. Solution that we solved for mathematically, but when we plug it back in, it doesn't work. That doesn't work. So we just get a equals 0. That's our one answer. Okay, next problem. We're going to skip down to number 11. And for number 11, it says the square root of 3n plus 6 is equal to n plus 2. All right, so first off, we want to get the radical all by itself. It is, so now I can cancel that radical sign by squaring, and I have to do the same thing to this whole side. This cancels this, and I'm left with 3n plus 6 equals, and now we'll square this guy. So n squared plus 4n plus 4. Remember when you have one binomial that's times itself that's squared, square the first term, square the last term, and the middle is first times last times 2. Okay, easy peasy. So I have all the pieces of a quadratic. I want to move everything to one side of the equal sign. So I'm going to subtract 3n, and I'm going to subtract 6. So I'm going to end up with n squared plus n minus 2 equals 0. And now I can factor. Okay. Factors of negative 2 that add up to positive 1 are positive 2 and negative 1. N plus 2, n minus 1. This is like similar to one we've already done. And so if we set each of these parentheses equal to 0, we get n equals negative 2 and n equals positive 1. Now we need to go back and plug these both in to the original equation to see what works. So first, I'm going to use n equals negative 2. So square root of 3 times negative 2 plus 6 equals negative 2 plus 2. Okay, and now we can simplify. 3 times negative 2 is negative 6. Negative 6 plus 6 is 0 equals negative 2 plus 2 is 0. Square root of 0, 0, so that works. Okay, and then second, I'm going to plug in 1. So square root of 3 times 1 plus 6 equals 1 plus 2. 1, 1. 3 times 1 is 3 plus 6 is 9. 1 plus 2 is 3. 3 equals 3. That works. So there's no extraneous solutions here. Everything works. So n is 1 and n is negative 2. Awesome. Next problem we're going to do is number 13 on the study guide. Okay, for number 13, the problem says r plus the square root of 2 minus r equals 2. Okay, so first thing I want to do is get the radical by itself. Right now I have this plus r, so I want to subtract r and subtract r. So I'm going to end up with, these are going to cancel, and I'm going to get square root of 2 minus r equals 2 minus r. Then I want to get rid of the radical, so I'm going to square it, and I got to square this guy. So this is going to cancel with my sign, and I'm going to get 2 minus r equals 2 squared, which is 4. I meant to write 4. I almost wrote 2 squared. 4 minus, the middle term is first times last times 2, so that's 4r, and then plus r squared. Okay, so I have all the pieces for a quadratic. I want to move everything to one side of the equal sign, so I'm going to subtract 2 and add r, and so I'll end up, when I put it in standard form, with r squared minus 4r plus r is minus 3r, and then 4 minus 2 is positive 2. Okay, and then that's equal to 0. So now I can factor. Okay, factors of positive 2 that add up to negative 3 are negative 1 and negative 2. Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. So that works. And then we have an r and an r. We're going to set each of these equal to 0, 0 product property. So r minus 1 is 0. R would have to equal 1. R minus 2 equals 0. R would have to equal 2. So we have two solutions. Now we need to go in and plug them into the original equation to make sure they both work. So first I'm going to plug in r equals 1. So 1 plus the square root of 2 minus 1 equals 2. 1 plus the square root of 1 equals 2. 1 plus 1 equals 2. 2 equals 2. Yes, that works. And then second, I want to try out r equals 2. So 1 plus the square root of 2 minus 2 equals 2. 1 plus the square root of 0 equals 2. 1 equals 2. They are not equal, so this is an extraneous solution. So r equals 1 is not, sorry, r equals 2 is not one of our answers. Only r equals 1. Okay, and now we have, let's see, we're getting close. 2 more left. Last two. They're starting to get a little longer. All right, number, if you're following along, number, what are you, 13, 15, and then 16, and then we're done. Number 15 says negative 2 times the square root of x over 8 equals 15. Okay, so we're going to stick with our rules. First thing we have to do is get the radical sign all by itself. So I want to get rid of negative 2. So I'm going to divide by negative 2. And I'm going to divide by negative 2 over here. So these go away. So I'm left with the square root of x over 8 equals negative 15 over 2. Then I want to get rid of the radical, so I'm going to square it. And I got to do the same thing over here. Okay, so this cancels with this, and I'm left with x over 8 equals. Now you can say, like, this is not simplified, this radical here, because remember you can't have a fraction under a radical in simplest form. But we're not really simplifying that, we're solving it. So we're just going to go ahead and start solving, and eventually we get rid of this and we're just left with a fraction. So you can do that. You don't have to simplify it first. You just have to make sure at the end your answer is totally simplified. Okay, so negative 15 squared, I believe, is 225. Let me check. Yep, 225 over 4. And then I want to solve for x, so I'm going to multiply both sides by 8. These go away, and x equals, I only got one answer for this one. Interesting. X equals 225 times 2 is 450. That's my only solution. So I want to go back, plug it in, make sure it works. So we'll say negative 2 times the square root of 450 over 8 equals 15. Now, I already know this isn't going to work. How do I know that? Because this is a positive number, and it's being multiplied by a negative number. So a negative times a positive should be a negative, and that's not what we have. But I'm going to go ahead and simplify. All right, negative 2 times the square root of, I'm going to go ahead and divide 450 by 8. And I get 56.25, and then I take the square root, and I get 7.5. So I'm going to multiply this by 7.5 equals 15. Negative 2 times 7.5 is negative 15. But that is not equal to positive 15, and that was our only solution. So we're just going to say no solution. And when you think about it, there isn't anything that makes this a true statement. If you're multiplying a negative times a positive, radicals always have to be positive, then you're not going to get a positive answer. Nothing, no number is going to make that true. If we plugged a negative in here, it wouldn't work because then you'd have a negative under a radical, so you can't do that. If we plugged a 0 in here, it would be 0, not 15, so it doesn't matter. Nothing's going to make this correct. Okay, and then last problem we're going to do is number 16. For number 16, we have square root of x squared minus 4x, 6x squared minus 4x, sorry, equals x plus 2. All right, so first thing we want to do is make sure our radical is by itself, which it is, so then I can get rid of it by squaring. And whatever I do on one side, I got to do to the other. These cancel each other out, so I'm left with 6x squared minus 4x equals, and then this is being multiplied by itself. So I square the first term. First times last times 2 is the middle term, and then I square the last term. Okay, so I've got all the pieces of a quadratic now. Now I need to combine like terms and move everything to one side of the equal sign. Well, if I move this guy, if I get rid of this guy, I'm going to have a negative 5x squared. And I don't want negatives. I don't want a negative x squared term. So I'm going to subtract this. I'm going to move all of these over here. Okay, so 6x squared minus x squared is 5x squared. Negative 4x minus 4x is negative 8x. And, and then plus 4, so I'm going to subtract 4, and I get negative 4. Okay, so here's my problem. Now, to factor this, remember I have to come up with, I can use the quadratic equation. Can't complete the square because you can't have a number in front when you complete the square. I can also factor, right? So I can come up with, when I multiply 5 times negative 4, I get negative 20. So all the factors of negative 20 that add up to the middle term, negative 8, and those are going to be negative 10 and positive 2. So I'm going to rewrite this equation. 5x squared minus 10x plus 2x minus 4 equals 0. This middle green part is the same thing as this part. They're equal to the same thing. I just split that up into 2 terms so that now I can group. Okay, that's just the process of solving when you have a number in front and you're factoring. All right, so now I group. And I can divide both of these by 5x. And I can divide both of these by 2. So then after I divide, I put the number I divided by in front. Everything left over after I divide in parentheses, plus 2 in front. Everything left over, parentheses. 5x squared divided by 5x is x. Negative 10x divided by 5 is negative 2. 2x divided by 2 is x. Negative 4 divided by 2 is negative 2. So now we notice that our parentheses match, right? So just like I did up here, I took these 2 terms and I divided by what I could from each of these. I'm going to do the same thing here. I've got 2 terms separated by a plus sign, and I can divide both of these terms by x minus 2. So I'm going to do that. And what did I do here when I divided by 5x? I rewrote this and I put the 5x out front. So if I'm going to divide these by x plus 2, or sorry, x minus 2, I'm going to rewrite it and put x minus 2 out front. So x minus 2 goes out front. And then after I divide each term by x minus 2, what's left over? Well, this cancels with this, and I'm just left with 5x. And then in the second term, this cancels with x minus 2, and I'm just left with positive 2. Okay, so far, so that was a lot of factoring right there, but you can go back into our lessons where we factored into chapter 8 and review that if you need to. It's whenever we have a number in front of x squared. And I think it was like lesson 8, 7, something like that. And now I can set each of these equal to 0 to solve, right? So x minus 2, if that equals 0, x would have to equal 2. If 5x plus 2 equals 0, x would have to equal negative 2 over 5. So there's my two solutions. Now I want to plug them both back into my original equation way up here at the top and make sure they both work. Okay, so first I had x equals 2. I'm going to plug that in first. Square root of 6 times 2 squared minus 4 times 2 equals 2 plus 2. Now I just got to simplify. 2 squared is 4. 6 times 4 is 24 minus 8 equals 4. 24 minus 8 is 16. And the square root of 16 is 4. So that is true. That works. Okay. Second, my other solution is negative 2 over 5, negative 2/5. So I'm going to have square root of 6 times negative 2/5 squared minus 4 times negative 2/5 equals negative 2/5 minus 2. All right, this looks tricky and it's fractions and nobody likes fractions. That's why I saved it till the end. All right, so negative 2 over 5 squared is going to be positive 4 over 25. And 6 over 1 times 4 over 25 is going to give us 24 over 25. So I'm going to have 24 over 25 for this whole problem, this whole thing, minus 4 times negative 2 over 5 is negative 8 over 5. And when I minus a negative, I'm going to plus, equals, and then this is negative 2 over 5 minus 2 is the same thing as 10 over 5. So negative 2 minus 10 over 5. Negative 2 minus 10 over 5 is negative 12 over 5. I feel like I messed that up somehow. Oh, it's plus. It's plus. Negative 2 plus 10 equals 8 over 5. Just kidding. I knew I messed that up. Yeah, 8 over 5. So then we can go ahead and square both sides. This cancels with this. So I'm left with 24 over 25 plus, I can go ahead and put this, make the denominators the same. Multiply this by 5, so I have to multiply the top by 5, and I get 40 over 25. And that should be equal to 64 over 25, because 8 squared is 64, 5 squared is 25. And 24 plus 40 is 64. So that works. Even though it was a lot of work and it was fractions, that answer actually works. So both of these answers work. We have no extraneous solutions. I can highlight both answers. We're done. All right, if you guys have any questions at all, if you caught anything in the video, you want to talk about it, please let me know. You can email me or message me here on the video, and I'll be happy to get back to you.